Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using the method of undetermined coefficients. So let's get going. Problem: solve d square plus 3d plus 2 into y equal to sine x. Okay. We are given a differential equation d square plus 3d plus 2 into y equal to sine x. Consider as equation number 1. Say. So the given differential equation is of the form, it is an operator form, right? Say f of d into y equal to some function of x, a q of x form, where f of d equal to d square plus 3d plus 2 and q of x equal to sine x. Here the general solution to this equation is given by y equal to yc plus yp, where yc is a complementary function, yp is a particular integral. We'll find yc using the auxiliary equation and we'll find yp using a trial method. Okay, we can say like that. Fine. Now coming to yc, we'll find yc using the auxiliary equation and later we'll go for yp. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square plus 3d plus 2, right? Let's replace the differential operator dym, so that we'll get f of m equal to m square plus 3m plus 2. Then the auxiliary equation becomes m square plus 3m plus 2 equal to 0. Now we need to find roots to this equation, right? Let's split this 3m as 2m plus m, right? Take m common from the first two terms, we'll get m times m plus 2 and the next two terms remains the same. Now take m plus 2 common from the two terms, we'll get m plus 2 into m plus 1 equal to 0. Now we equate each factor to 0. When m plus 2 equal to 0, m equal to minus 2, and when m plus 1 equal to 0, m equal to minus 1, right? The roots are m equal to minus 2, minus 1, which are real and distinct. Therefore, the roots are real and distinct. We know that when two roots, say m1 and m2, are real and distinct, then yc looks like one constant into e power 1 root into x plus another constant into e power another root into x. Now using this formula, we'll write a complementary function. Y is equal to one constant into e power 1 root, say minus 2 into x plus another constant into e power another root into x, which gives us c1 e power minus x, sorry, it's 2x, right? Minus 2x plus c2 e power minus x. Therefore, y is equal to c1 e power minus 2x plus c2 e power minus x. We have q of x equal to sine x, right? The RHS part of the given equation, which is sine x, right? Fine. Now observe q of x and the functions of yc. The terms which involves the functions of x. E power minus 2x, e power minus x, and here we are having sine x. Do we have any common terms in q of x and yc? No. Therefore, q of x has no common term with yc, right? Therefore, yp will be the linear combination of q of x and all its linearly independent derivatives okay, fine. See, in q of x we don't have any quotient to sin x, right? Fine, and it's just sin x. We have a formula. If q of x equal to sin x, then yp will contain one constant into sin x plus another constant into cos x. Here a0 and a1 are constant quotients, or these are the undetermined quotients which we have to find. Okay, so this is the direct formula if you have q of x equal to sin x. Okay, or if you have q of x equal to sin x or cos x, then this will be the formula for yp. Okay, when it comes to q of x has no common term with yc, right? Fine. If q of x has no common term with yc and you have q of x is sin x, or if you have sin ax, or cos ax in q of x, then yp will be a0 sin ax or cos ax plus a1 cos ax. Okay, well, now formula apart, we'll see how to find yp with the help of q of x. Okay, let's see. Now we are going to find suitable yp such that it satisfies the given equation. Okay, using q of x and yc will find the yp. Okay, but in our case the terms of q of x and we don't have any common terms in q of x and yc, right? So we'll just go with q of x. Okay, this is the q of x, and as I said, yp must contain linear combination of q of x and all its derivatives. It means derivatives, linearly independent derivatives of q of x. Okay, if we have q of x equal to sin x, then find the derivative of sin x. Say q dash of x equal to derivative of sin x is cos x. Find its derivative, then you'll get q double dash of x, which is equal to minus sin x, right? Find another derivative. Derivative of minus sin x is minus cos x, right? Finally, our q power 4 of x equal to minus of minus sin x, which is equal to sin x. See, you'll get sin x, cos x, sin x, cos x, sin x, cos x. It's just continuous. Okay, which says that yp should be picked from q of x and all its derivatives, which involves only sin x and cos x. Just write sin x and cos x in one bracket. Okay, so yp, we should find yp using this, or you'll get yp from this set, we can say. Okay, we have written the functions of q of x and all its derivatives. Okay, simply we'll get sin x and cos x and nothing else while finding derivatives of q of x, right? See, the set involves q of x and its derivatives, right? Its derivatives involve cos x, sin x, cos x, sin x, right? So yp will be the linear combination of q of x and all its linearly independent derivatives. See, this is a set I wrote from q of x and all its derivatives. So what I have, sin x and cos x here, right? Now using this, we'll write yp. Yp equal to, it should be a linear combination of q of x and linearly independent derivatives. Okay, so take one constant into one function plus another constant into another function, right? So this is a yp. right? This is the way you have to remember. It is good if you remember. Otherwise, you can just blindly go for the formula. Yp equal to a naught sin x plus a1 cos x when q of x is sin x or cos x. Likewise, a naught sin ax and a naught cos ax when q of x is sin ax or cos ax. Okay, this is a formula. You can just blindly use this. But if you understand how to find yp using q of x and all its derivatives, it will be good for you. You won't make any mistake. If you just blindly follow the formula, you may tend to make mistakes while finding yp. Right? Now we got yp. Let yp equal to a sin x plus b cos x. So we have chosen a yp which satisfies the given differential equation, right? Fine. We have the given differential equation, right? We can write this as, okay, it is nothing but, right? Consider as equation 1. We have chosen yp such that it satisfies equation 1, which is nothing but, we'll write in terms of yp. Since it satisfies the given equation, right? Which means we can just apply yp in equation 1, isn't it? Fine. Now we are having yp and we need to find yp dash and yp double dash. Yp dash equal to a into derivative of sin x is cos x plus b into derivative of cos x minus sin x, which gives us yp dash a cos x minus b sin x. Now find yp double dash, which is equals to a into derivative of cos x is minus sin x minus b into derivative of sin x is cos x, which gives us minus a sin x, that is yp double dash equals to minus a sin x minus b cos x, right? Therefore, yp equal to a sin x plus b cos x, yp dash is a cos x minus b sin x, and yp double dash is minus a sin x minus b cos x, right? We have chosen yp such that it satisfies a given equation. So we'll substitute yp dash and yp double dash in this equation, or we can say that we'll just substitute yp double dash, yp dash in equation 1, right? We have yp equal to a sin x plus b cos x and yp dash equal to a cos x minus b sin x and yp double dash equal to minus a sin x minus b cos x, right? We can write equation 1 as yp double dash plus 3yp dash plus 2yp equal to sin x. Now substitute yp dash and yp double dash in it. Yp double dash is minus a sin x minus b cos x plus 3 times yp dash a cos x minus b sin x plus 2 times yp a sin x plus b cos x equal to the RHS part sin x. Now we need to simplify it. This gives us minus a sin x minus b cos x plus 3a, it's 3, okay, not b, it's 3. 3a cos x minus 3b sin x plus 2a sin x plus 2b cos x equal to sin x, right? Fine. Now take sin x common from all these three terms. We'll get sin x times minus a minus 3b plus 2a plus, now take cos x common from all these terms. We'll get, again, just write this as into sin x better, okay? Now take cos x common from these three terms. You'll get minus b plus 3a plus 2b into cos x equal to sin x, right? Which uses minus a plus 2a gives a minus 3b into sin x plus minus b plus 2b gives b plus 3a into cos x equal to sin x, right? Now we'll equate the equations of like terms to find the values of a and b. Equating the equations of like terms, I'll begin with sin x. Just equate the equations of sin x. We'll get a minus 3b equal to 1. And now equate the equations of cos x. b plus 3a equal to, you don't have any term involving cos x in RHS, so take it as 0. You can just write it as 3a plus b equal to 0. Now we'll solve these two equations in order to find a and b. So what I'll do is, I'll try to cancel the terms involving a from these two equations. So I need a 3 here, right? So I'll just multiply 3 to this equation and then solve these two, right? Solving, consider as some equation a or equation b. We'll get 3a minus 3 3s are 9b equal to 3 1s are 3. Write this equation as it is. You'll get 3a plus b equal to 0. Now change the signs. See, just multiply it with minus 3x otherwise and solve these two. 3a plus b equal to 0. I'll just multiply with 3. I'll get 3a minus 9b equal to 3. Now I'll change the signs. 3a minus 3a gets cancelled. b plus 9b gives 10b equal to minus 3. From this we'll get b equal to minus 3 by 10. Right? Now substitute b value in any of these two equations. I'll go for the second one. So take this b to RHS, then you'll get 3a equal to minus b. Now take this 3 to RHS, you'll get minus 1 by 3 into b. Now substitute the value of b, since b equal to minus 3 by 10, which gives us minus into minus plus 1 by 10. Therefore, a equal to 1 by 10 and b equal to minus 3 by 10. Let's see what happens if we substitute in a minus 3b equal to 1. Okay. A equal to, just take this term to RHS, you'll get 1 plus 3b equal to 1 plus 3 into, write the value of b, minus 3 by 10, which gives us 10 minus 3 3s are 9 by 10, which is 1 by 10. So therefore a equal to 1 by 10, you'll get the same thing. Well, now we got the values of a and b. Now coming to yp. We have yp equal to a sin x plus b cos x. Now substitute the values of a and b here. we'll get 1 by 10 into sin x plus minus 3 by 10 into cos x, or we can write this as 1 by 10 into sin x plus into minus minus 3 cos x. Just take 1 by 2 common from these two terms. Okay, so therefore yp equal to 1 by 10 times sin x minus 3 cos x. We got yp and yc. Let's now write the general solution. Therefore the general solution is given by y equal to yc plus yp, then y equal to c1 e power minus 2x plus c2 e power minus x plus yp, 1 by 10 into sin x minus 3 cos x, right, which completes the problem. Well, we got yp, but you may have some doubt whether yp is correct or not, right? So for that, we can just verify it using the formula 1 by f of d into q of x. You can use this formula and verify the answer. Okay, let's check it out. Verification. Yp equal to 1 by f of d into q of x, right? Where f of d is d square plus 3d plus 2 and q of x is sin x. So this is of 1 by f of d into sin bx form, right? So here we need to find d square, which is minus of b square. Just compare sin x with sin bx, and for b equal to 1 we'll have minus 1 square, which is minus 1. If you substitute d by minus 1, you'll get the non-zero term in the denominator. Just replace d square by minus 1, okay? By replacing d square by minus 1, the denominator is non-zero. You'll get 3d plus 2 minus 1 is plus 1 into sin x. Now multiply and divide 3d minus 1 to the fraction. You'll get 3d minus 1 by, this is of a plus b into a minus b form, right? You'll get a square minus b square, which gives us 3d minus 1 by 3d square is 9d square minus 1 into sin x. Again, replace d square by minus 1 in the denominator. If you replace d square by minus 1, you'll get 9 into minus 1 gives minus 9 minus 1, which is minus 10. Okay, the denominator is non-zero by replacing d square by minus 1 in the denominator. So just replace d square by minus 1. You'll get 9 into minus 1 into sin x, which is equals to 3d minus 1 by minus 9 minus 1 into sin x, which gives us minus 9 minus 1 is minus 10. So you'll get minus 1 by 10 into 3d minus 1 into sin x, which is equals to minus 1 by 10 into 3 d sin x, that is derivative of sin x, minus sin x, which gives us derivative of sin x is cos x minus sin x. Just multiply these two terms with this minus, then you'll get 1 by 10 into minus 3 cos x plus sin x. You can write this as 1 by 10 into sin x minus 3 cos x. This is what we got, right? So our yp is correct. Fine. We have solved the problem. Well, we have discussed a problem using the method of undetermined coefficients in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.